Two galaxies are about to collide, yet almost nothing explodes. Wait, what? Our instincts say chaos and wreckage, but the universe has a twist. Stars mostly miss. Gravity does the choreography. In the next minute, I'll show you how a crash becomes a slow-motion dance that builds new stars, steers black holes together, and reshapes entire galaxies. If you think collisions mean destruction, this will flip your blueprint of the cosmos. Let's zoom in on what really happens when islands of hundreds of billions of stars pass through each other. The surprises are everywhere, and the drama isn't where you expect. Let's begin. First, let's talk about tides. We're familiar with them on Earth, where the moon's gravity pulls on our oceans, creating bulges. Now imagine that on a galactic scale. As two galaxies approach, their immense gravitational fields reach out and grab hold of each other. They raise vast tides in each other's stellar disks, distorting their elegant, spiral shapes. Those tides stretch and twist the galaxies, drawing out long, shimmering bridges of matter between them and spectacular tails that arc into the void, streams of stars and gas flung outward like pulled taffy. It's beautiful, predictable, and pure gravity at work. So with all these stars flying around, what about star-star pileups? It seems inevitable, but it almost never happens. The space between stars is so mind-bogglingly enormous that even in a galactic collision, individual stars mostly sail past one another untouched. To put it in perspective, if the sun were a grain of sand in New York City, the nearest star would be another grain of sand in Chicago. Now, picture two swarms of fireflies drifting through an empty stadium, plenty of near misses, almost no direct crashes. Gravity sculpts the crowd, but direct impacts are vanishingly rare. Gas and dust, however, are a completely different story. Unlike stars, which are tiny point-like objects, interstellar gas clouds are vast, diffuse, and span light years. They can't just ghost past each other. Instead, they feel drag, they compress, and they create powerful shockwaves. Where these colossal clouds slam together, the immense pressure causes them to collapse under their own gravity, igniting furious bursts of star formation known as starburst regions. Newborn clusters blaze to life. The most massive of these new stars live fast, die young, and pepper the scene with supernovae that stir and sculpt glowing nebulae. It's a stellar nursery, with fireworks. At the hearts of most large galaxies, including our own, sit supermassive black holes, monsters millions or billions of times the mass of our sun. As their host galaxies interpenetrate, these central giants feel a cosmic break. This effect, called dynamical friction, is caused by the gravitational drag from the surrounding sea of stars and dark matter, which saps their orbital motion. The pair of black holes inevitably sinks toward the new, combined center. For a time, you can get a spectacular phenomenon. Dual-active galactic nuclei, two intensely bright cores, each feeding on a swirling disk of gas and shining across the universe. Eventually, on much longer timescales, perhaps hundreds of millions of years after the galaxies have merged, the two black holes form a tight binary system. They orbit each other in a final, deadly dance. As they whirl closer and closer, they shed enormous amounts of energy in the form of gravitational waves, ripples in the very fabric of space-time. This process is unstoppable. They spiral together, likely merging in a final, violent burst of these waves. We won't hear equations tonight, just know the finale writes its signature on the universe itself. Meanwhile, for the billions of individual stars, life goes wild. Their once stable, gentle circular orbits around the galactic center are thrown into chaos. The gravitational tug-of-war turns these paths into eccentric swirls, loops, and rosettes. Entire groups of stars are tossed out into vast ghostly arcs and ribbons called shells and tidal streams, which wrap around the merged remnant. Star clusters, once residents of the spiral arms, migrate. Some are flung outward into the halo, while others sink toward the new, more chaotic center. Through it all, the unseen scaffolding of the universe sets the stage. The dark matter halos. These huge invisible cocoons of mysterious matter are far larger and more massive than the visible galaxies they contain. They are the first to make contact, and their immense gravity steers the entire encounter, soaking up and redistributing orbital energy like a vast cosmic shock absorber. If you want to forecast the dance, you have to follow the dark matter. These cosmic encounters rarely end in a single, decisive pass. More often, the galaxies swing through each other, separate, and are pulled back by gravity for another round. Each pass strips more material, stokes more starbursts, and tightens the gravitational embrace. It's a process of gradual assimilation, not a head-on collision. Think of orbital traffic merging lane by lane over a long stretch of highway, not a single instantaneous crash at an intersection. The timescales involved are simply epic, far beyond human comprehension. A dramatic first pass, with tidal tails unfurling, might last for tens of millions of years, but the full process of coalescence, from first approach to the final settling down, often takes hundreds of millions to a few billion years. It's a form of choreography you can only watch in time-lapse, with gravity humming the same patient, relentless tune throughout the entire performance. If we could zoom in on the action, we'd see the intricate details. Lanes of gas and dust twist into luminous knots where new stars are being born. Dark filaments of dust trace the invisible shock fronts where gas clouds collide. Bright blue clusters of young hot stars flicker into being, only to fade over millions of years. It looks chaotic, but the underlying physics is beautifully simple. Gravity guides, pressure resists, and radiation from newborn stars pushes back. After hundreds of millions of years, the frenzy begins to cool. The vast reservoirs of cold gas, the fuel for star formation, get used up in the initial starbursts, or they get heated by supernovae and blown out of the galaxy altogether. Star formation wanes, and the fires die down. The once spiral pair, now thoroughly mixed, relaxes into a new stable configuration, a rounder, more uniform remnant, often an elliptical galaxy, populated by older, redder stars and lacking the cold clouds needed to spark new suns. But even after the main event is over, the new galaxy often keeps faint scars of its violent past. With deep imaging, astronomers can spot these clues: faint tidal tails, ghostly loops of stars, and delicate shells limbing the outer halo. They read these marks like forensic lines on a cosmic report, deducing the story of the merger, who merged, how massive they were, from what direction they came, and when it all happened. This isn't just theory. We see this happening all across the universe. The antennae galaxies are a classic example, a chaotic scene of intense starbursts and tangled dust, captured in stunning detail by Hubble and the James Webb Space Telescope. The mice galaxies showcase those incredible tidal tails, streaming away for hundreds of thousands of light years. These snapshots, frozen in time, confirm our models and show us the beautiful, messy reality of galactic transformation. And these same models give us a preview of our own cosmic future. The Milky Way and our neighbor Andromeda are on a collision course, set to merge in about 4.5 billion years. The odds are, our sun and its planets won't hit another star, but our entire solar system will be tossed into a new, sweeping orbit. The view from a future Earth will be spectacular, Andromeda swelling to dominate the night sky, then two galactic cores circling each other in a luminous billion-year duet. Let's do a quick recap. 1. Gravity raises tides that stretch galactic disks into long tails and bridges. 2. Stars almost never collide because space is too vast. It's the gas clouds that provide all the drama. 3. Gas collisions trigger massive starbursts, which then fade as the fuel runs out. 4. The central supermassive black holes sink to the center, pair up, and likely merge much later in a burst of gravitational waves. 5. Individual stellar orbits are scrambled, creating shells and streams that haunt the new galaxy's halo. 6. The invisible dark matter halos are the puppet masters, guiding the entire show and absorbing energy. 7. The whole story unfolds not in one crash, but over hundreds of millions to a few billion years, with multiple passes before the final embrace. And 8. The typical outcome is a larger, smoother elliptical or lenticular galaxy. The spiral arms are gone, the dust lanes fade, and with the cold gas depleted, major star formation is quenched. It's not a wreckage yard, but a fundamental reorganization into a new, more mature state. Think of the universe as a grand orchestra. The invisible dark matter sets the tempo. Gravity carries the deep, resonant melody. The colliding gas clouds are the crashing cymbals and booming crescendos. And the spiraling black holes bring the deep final percussion. When two galaxies meet, the cosmic score swells into a symphony. But the instruments themselves rarely ever collide. It's all a matter of perspective. From afar, you see the magnificent architecture, tails unfurling and cores converging in a silent cosmic ballet. But from inside, for any beings living there, The experience is a gradual one. A slow warping of the constellations, unfamiliar rivers of stars rising in the night sky, and gentle gravitational nudges over millennia. Both views are true, just different seats in the same cosmic theater. So, what really happens when galaxies collide? It's a process of profound transformation. Tides sculpt, gas ignites, black holes rendezvous, and over eons, the beautiful chaos settles into a new, grander whole. The result is often a serene elliptical galaxy, glowing with the blended light of trillions of stars, a quiet monument, holding the memory of a grand encounter. Look up and remember, the universe prefers dances to crashes,